పెట్టుకుంటా మ్యూట్ చేసి. Hello, is it audible, right? Last class what we are discussing, right? Yesterday I didn't take the class, right? Last class. Hmm? The nomenclature almost all it's keep on continuing, right? Actually it never ends. Hello. So today we'll discuss in the GOC. Okay. First, no. Generally chemistry means what? Reactants is converting into products, right? Reactants, products. So first, to form a bond, first what we need to do, we need to break the bond. Bond breaking is two types, Nana. Here is generally organic compounds are ionic bond or covalent bond. Hello. Organic compounds, covalent bond, mutual sharing of electrons takes place, right? Mutual sharing. So the covalent bond we can break two types. One is homolytic cleavage, other one is heterolytic cleavage. Homolytic cleavage means what, Nana? We'll get radicals. Equal cleavage. For example, if I am taking heterolytic cleavage, unequal cleavage, C plus C minus. So first we need to know types of breaking: homolytic, heterolytic. Homolytic, heterolytic. No? For example, try to understand. The bond is double bond is there. Imagine, for example, some H plus is coming, wants to attack over here. Okay. This bond I'm just writing with this green color. It's coming like this. This is which type of cleavage? Homolytic or heterolytic? Heterolytic. So here is, we'll get the bond like this, and this carbon will get which charge, Nana? Positive charge. Okay. But here I didn't write the negative charge, right? That bond is came and given the H plus. The electrons are given to H plus. Right? This is, for example, C double bond C. I'm just adding the Br radical. Imagine I'm adding the Br radical over here. So then this bond undergoes which type of cleavage? Homolytic cleavage, Br, and we'll get the radical over here. Then, hello. Yeah, Cl is having the one radical, and this radical, Br radical. Br is having one radical. This radical like this. So Br is having one radical, is forming the bond like this. So first try to understand how the bonds are breaking in the reactions. For example, now I'm H plus I'm adding, right? I'm adding the H plus over here, this carbon. So now, which type of cleavage takes place, homolytic or heterolytic? H plus doesn't have any electrons, right? Hello. H plus, now it has to undergo heterolytic cleavage. What exactly happens? This bond is coming over here. We'll get CH3, CH, CH2. I'm just writing with this is yellow color bond H, and here we will get the positive charge. This is which type of cleavage, no? Heterolytic cleavage. Okay. H plus is attacking over here, so like that. How the positive charge? So carbon, if it is having the positive charge, we are called as what now? This is, hello, what now? Carbocation. Carbocation. Here we are getting the carbocation. Which carbocation it is? Secondary, 2-degree carbocation. Carbocations are 3 types. Write it down. Carbocations are 3 types. So this is 1-degree carbocation. Primary, this is secondary, this is tertiary carbocation. The carbocation attached the carbon ring. This carbon is 1-degree carbon, right? So here is what? 2 carbons are directly attaching over here, 2-degree. The carbocation carbon, it is attached to 3 carbons, 3-degree carbocation. Okay. So generally, which carbocation is more stable? 1-degree, 2-degree, 3-degree. Which carbocation is more stable? Vaishali? 3-degree. 3-degree carbocation. I'll explain why 3-degree carbocation and all I'll discuss. So first, how the bond is breaking, I'm just discussing. Right. So the one compound is like this, and for example, one OH minus, CN minus, right, is coming and attacking over here. So generally, let me know, carbon is having how many bonds now? Carbon is having how many bonds always? Carbon is always having how many bonds? 4 bonds. Either all are single bonds, or one double bond, 2 single bonds, or one triple bond, 1 single bond, or 2 double bonds. These possibilities are there, right? So now in this case, carbon is already having how many bonds? This carbon already having how many bonds now? 4 bonds, right? Hello. So the nucleophile is coming and attacking over here. So one of the pi bond undergoes heterolytic cleavage now. Carbon and oxygen, which is more electronegative? oxygen. So the electrons are moves like this: CH3, CO minus, CH3, CN. So how the bond here is heterolytic cleavage takes place. So I am just speaking about only how the bond is cleaving, how the bond is breaking, right? Then now the reactants, the chemistry, reactants are converting into products. So first what we need to do, first we need to break the bond. The breaking of bond, I told you two types. One is homolytic cleavage, one is heterolytic cleavage. If it is undergoes homolytic cleavage, means equal cleavage, we'll get carbon radicals. Here is right. This we can say carbon free radical. Carbon free radical. If it is undergoes heterolytic cleavage, the one which is having the positive charge, I told you what? Carbocation. The one which is having negative charge, we are called as Carbanion. One is carbocation, one is Carbanion. Okay, write it down. This is carbocation, this is Carbanion. So generally these three we are called as what? Carbon free radical, carbocation and Carbanion. Generally these three we are called as hello, carbocation, Carbanion or carbon free radicals. Generally these three we are called as reaction intermediates. What we could say, reaction intermediates. Okay, hello. So then the product is forming. So imagine 1 to 10th we have just studied a school, some school, imagine. So generally 11th and 12th we are called as what? 11th and 12th we are called as what? Hello. What now? Intermediate, right? 11th and 12th generally we are called as intermediate. So intermediate, this intermediate is very important in our lives. Yes or no? Why you people are attending the class right now? Because you are in the intermediate. So then you are going to write NEET or IIT or any other examinations. So if you perform well in this intermediate, so our life, for example, if you are securing IIT or doctor something, right? Our life will be settled. Throughout our life will decide this 11th and 12th. Yes or no? If you are good at 11th and 12th, you will get the good rank in the entrance exams. Yes or no? Hello. The same time, how this intermediate, which is important in our lives, when the reaction takes place, these reaction intermediates also that much of important. These reaction intermediates will decide the product. These reaction intermediates will decide the product, which is major product and which is minor product. So in the total organic chemistry, the reaction intermediates are very important. In that, important one is carbocation, Carbanion, carbon free radical, and carbenes are there. I'll discuss about the carbenes also. Okay. So now these generally were called as reaction intermediates. So generally imagine, I'll explain carbocation which 3 degrees more stable than 2 degree, then 1 degree, right? Imagine, for example, how it is HBr I'm just taking the H plus. This H plus is attacking the first position, first carbon, or second carbon, where it is attacking. Let me know. So first, this is second, third. The H plus is attacking majorly at which position? Second. Ananya, second. Remaining guys, everyone should tell me the answer. The H plus majorly will attack at which position? Come on, come on. Isha, Dikshita, Vaishali వింటున్నావు? ఎక్కడ అటాక్ అవుతుంది? Where it is attack? Varun, second carbon. Varun, hello. Gautam, second carbon. Right, so we'll do one thing. I'll write the both and you need to decide where it is attacking. So H plus is attacking at which position is decided by this carbocation intermediate. How will this? For example, if H plus is attacking the first position, what exactly happens? Hello. CH3, CH, CH2, H plus. If it is attacks the first position. If it is attacks the second position, CH3, CH, H, CH2 plus. Now let me know, this is which carbocation? This is which carbocation? Hello, 2 degree. This is which carbocation? 1 degree. Which carbocation is more stable? Which carbocation is more stable? Yeah, 3 degree, 2 degree, 1 degree. Of course, here is 2 degree and 1 degree is there. So, which is more stable? 2 degree. 2 degree carbocation is more stable. Means now H plus will attack at first position or second position. H plus will attack at the first position. If H plus is attacks the first position, the bond is migrating, electrolytic cleavage takes place. We'll get this secondary carbocation. Got it? What I'm trying to say? Hello. C. That's only I'm telling, right? So if the H plus is coming attacking the first position, this is undergoes electrolytic cleavage is like this. So what exactly happens now? C, here is H, here is the positive charge. If it is attacks the second position, the bond is migrating like this here. Get the carbocation. This is 1 degree carbocation. This is 2 degree carbocation. 2 degree carbocation is more stable than the 1 degree carbocation. Try to understand what exactly happening here is just I am breaking the bonds. How I am breaking the bonds. Got it clear, everyone? Still anybody having any doubt? Hello? Vaishali, అర్థమైందా? So ఇప్పుడు bond, the CH3 CH double bond CH2, I am adding the H plus. H plus is having how many electrons? H plus is having how many electrons? H plus is having how many electrons? How the H plus is coming? For example, if I am taking the HBr, so H plus plus Br minus. Which type of cleavage is takes place? Homolytic or heterolytic? Heterolytic. So it's a bond is there, covalent bond, 2 electrons. The 2 electrons, heterolytic cleavage is takes place, will get H plus plus Br minus, because bromine is more electronegative, right? So that's the reason we got the H plus. Now the H plus electrons are taken by the Br minus. Now H plus is having how many electrons? H plus is having how many electrons now? 0. It doesn't have any electrons. Now for the formation of bond we need 2 electrons, right? For example, it wants to form the bond. We need 2 electrons. So for example, H plus is coming, wants to attack the first carbon. So one of this pi bond, double bond means one is sigma bond and one is pi bond, right? Hello. Double bond means one is pi bond and one is sigma bond. Which is stronger bond? Which is stronger bond? Which is weak? Sigma and pi. Sigma is strong, pi is weak. Because sigma is end-end overlapping takes place, head-on overlapping or end-end overlapping, whereas pi bond is formed by sidewise overlapping. So when sigma and pi both are there, so now which bond is breaking? Which is weak? Which is weak? Pi. So now the pi is undergoes which type of cleavage? Heterolytic cleavage takes place, right? Now CH3, CH, it is the positive charge, CH2H, right? Clear everyone? Got it? How the bond is breaking, I'm just speaking about only the bond breaking, and how the carbocation is forming. Done, no, everyone? Now carbocation is having how many electrons now? Carbocation is having how many electrons? Total how many electrons? Now this carbocation is having how many electrons? Imagine I'm just taking hydrogen, hydrogen, hydrogen. So how many electrons now carbocation is having? Total. How many bonds are there? 3 bonds. Each bond is having how many electrons? So total how many electrons carbocation is having? 6 electrons. 6 electrons. According to octet rule, the carbon should have how many electrons? Octet means what? 8 electrons. Any compound, if it is having the outermost shell, if it is having the 8 electrons, that compound is more stable. Now, is this carbocation stable or not? Not stable, because it is deficient with electrons, right? It needs electrons, or it no need? It needs electrons. How many electrons it needs? 2 electrons, right? So now the next concept I am going to explain. For example, try to understand CH3CH2 plus CH3CH plus CH3 CH3 right. So it is, try to understand CH3, this CH3 now. CH3 nature is what? Donating nature, Nana. Which nature? Electron donating nature. It's electron donating to the carbocation. Case number 1. In this case, 2 methyl groups are there. Both are donating. In this case, 3 are donating. Imagine carbocation doesn't have any electrons. So one is deficient with electrons now. For example, try to understand, you are going to a movie, right? You don't have the money. So first case 1, your father is giving 100 rupees for expenses, some to buy something, samosa or something, popcorn like that. The second case, your father is giving 100 rupees, your mother is also giving 100 rupees. The third case, your father is giving 100, mother is giving 100, and grandfather is also giving 100 rupees. So now in these three cases, where you are more comfortable, right? Simply 3 degree. So why 3 degree carbocation is more stable means it doesn't have the electron, it needs electron. So when it is needs the electron, so 3 are donating, in this case 2 are donating, it is only 1 is donating. So that's the reason. So 3 degree carbocation, or we could say the tertiary carbocation is more stable than, right, 2 degree than 1 degree. I'll discuss this is what is donating groups, what is withdrawing groups and all, I'll discuss in the inductive effect. Of course, but I'm just speaking about only carbocation, right? Carbocation is electron deficient species and it undergoes sp2 hybridization. Which hybridization? sp2, trigonal planar shape. Which shape, Nana? Trigonal planar. Trigonal planar means what? So like this, 3 are there, 3 are in the same plane, right? Trigonal planar shape. If one more is coming, that becomes tetrahedral. If 4 bonds are there, that becomes tetrahedral. But here is carbocation is having trigonal planar shape, right? So, and most important thing is this carbocation is having natural tendency of rearrangement. Which nature? Which nature? Natural tendency of rearrangement. By default, it undergoes rearrangement. Natural tendency means try to understand. For example, CH3, CH2, CH2 plus. So now this is which type of carbocation? 1 degree, right? Hello. 1 degree. So immediately the carbocation watching the adjacent carbon. This is which type of carbon? Carbons. 1 degree, 2 degree, 3 degree. This green carbon. 2 degree. The people who are confusing with the carbons, right? This is wrong. If carbon is attached with only one carbon, we can say 1 degree. This is 3 degree, 3 carbons. This is 1 degree. This is 2 degree carbon. This one, quaternary. This is 1 degree. This is 1 degree. This is 2 degree. This is 2 degree. This is 1 degree. Okay. So now this is which degree? 2 degree carbon, right? It is having the hydrogen. 2 hydrogens, right? 1 hydrogen I am writing like this. Here is hydride shift takes place here to here. CH3, CH plus, CH2, I am writing the H easy like. So now this is which carbocation? 2 degree carbocation. So that's all I am trying to say. This is which degree carbocation? 1 degree. So now the hydride shift is taking place. It's become which degree carbocation? 2 degree. So now in these two cases, which is more stable? 2 degree. So to get the stability, by default carbocation undergoes rearrangement. That rearrangement we are called as natural tendency of rearrangement. For example, try to understand. Did you ever travel in flight? So which seat you would like more, window seat or adjacent seats? Window seat. Okay, this is window seat. 3 seats are there, imagine. but unfortunately you got this seat. Okay, so now you are somewhat disappointed because you are liking window seat, you are more comfortable, you can watch everything right outside. If the window seat is there, we can watch, yes or no? But what exactly happened? You went, right, sat on the plane, right? Flight took off. So then these two guys were absent. These two guys are absent. These seats are vacant. What you will do? You will move to this. So you will move by your own, or someone air hostess coming. Why Ananya? Why can't you sit in that seat? So will you wait for the confirmation or will you jump directly? So that is called natural tendency of rearrangement. Why did you arrange? Right? Why did you jump? Why are you? So this, because this is more comfortable. Imagine this is 3 degree, this is 2 degree carbocation, this is 1 degree carbocation. Right? So when the car, how you are jumped naturally, right? So the same, the carbocation also rearrangement is takes place. So 1 degree becomes 2 degree. So this is we are called as natural tendency of rearrangement. Imagine, right? Everyone, anybody having any doubt? Hello, Gautam, are you following? Now, now try to understand. Now, the carbocation rearrangement takes place or not? The carbocation rearrangement takes place or not in this case? Hmm? Come on, tell me. Yeah, write it down. Do the rearrangement in your notes, right or wrong, doesn't matter. So adjacent, which carbon is there? No? Adjacent. Hmm? Now, is this takes place like this? What we will get? CH3, carbocation. Now, this is 1 degree carbocation, right? Now, this Nana? This, right? 2 degree carbocation. Stable, right? Hello. Now, once again, rearrangement is takes place or not? Once again, this carbon is which carbon? 3 degree. The hydrogen is, I am writing like this. What exactly happens? CH3. So this is becomes which degree carbocation? 3 degree carbocation. Come on, write it down. So 1 degree is jumping to 2 degree, 2 degree jumping to 3 degree. 3 degree to, is it jumping to somewhere? If it is jumping to here, 1 degree, 1 degree. Yes or no? So this is called natural tendency of rearrangement. This is called natural tendency of rearrangement. This is called natural tendency of rearrangement. Then Then Anna, imagine now try to do this. Try to do this. Still anybody is confusing, please let me know. I'll explain in a different mode. So this is 2-degree carbon, right? Rearrangement is takes place. Yes or no? Hello? So this is the hydrogen. First rearrangement is takes place, we'll get secondary carbocation. Now earlier hydride shift we did, but in this case there is no hydrogen, methyl group is there. So we can do the methyl group also rearrangement is takes place now. Methyl group also rearrangement is takes place. So now what we will get? CH3, CH3 positive charge, CH, CH3, CH3. Now which degree carbocation this is? 3-degree carbocation. Done? Hello? Hello? Done, Ram? Now like that rearrangement is takes place. Now I'm just speaking today about only the carbocation. This is one way of rearrangement of carbocations. Next, Nana, imagine so both are which degree carbocations? Both are same, okay? Both are not same, right? This is this. This is both are which degree carbo? Which degree? Both are 3-degree carbons, right? 3-degree carbocation. This also 3-degree carbocation. Now let me know which carbocation is more stable, 1 and 2, 1 or 2. Which carbocation is more stable? Gautam? Second one. Why second one? But here also ethyl group is there. Two carbons are donating more and more. Anyone? Vaishali? Dikshita? Varun? 1 or 2 now? Second one. Why second one? First one is having more bulkiness, okay? Your answer is correct, but explanation is wrong. Vaishali? Vintunnava? Yeah. A carbocation is more stable, Anna. First one. Why first one? Okay. Isha? Isha? Are you there? క్లాస్లో ఉన్నావా? హలో గౌతమ్, which one is more stable? Second one. Why? No, it needs electrons. Of course, if it is because the carbocation is deficient with the electrons. If someone is earlier, which I told you, you are going to the movie, right? In the third case, for example, if someone is giving you money, so will you say no? You need money, right? How much money if someone is offering, will you take? Yes or no? Hmm. So in this case, Nana, we need to cross-check with alpha hydrogens. Next level concept. The next level concept we are called as hyperconjugation. What, Nana? Hyperconjugation. Hyperconjugation. Right? Hyperconjugation. Hyperconjugation means the carbocation adjacent carbons were called as alpha carbons, Nana. Right? Carbocation adjacent carbons were called as alpha. Okay? This is beta. Alpha, alpha. Right? Alpha carbon is having the hydrogens. Those hydrogens were called as alpha hydrogens. Now in this case, this is alpha, this is alpha, this is alpha. Total how many alpha hydrogens are there? How many alpha hydrogens, Nana? 3 plus 3 plus 2, 6 plus 2, 8. 8 alpha hydrogens are here. In this case, how many alpha hydrogens? Alpha carbon, 3 alpha. How many alpha hydrogens? 9. 9 alpha hydrogens. Write one statement. More alpha hydrogens, compound is more stable. More alpha hydrogens, the carbocation, that carbocation is more stable. That carbocation is more stable because more hyperconjugation structures are coming. Of course, what are hyperconjugation structures? I'll explain you. Okay? But try to understand what is alpha carbon, what is alpha hydrogens, what exactly happen. Those things I'll try to explain. Got it? Sometimes both are 3 degree, 3 degree. If someone is asking you which is more stable, means what we need to do? What we need to do? We need to cross check alpha hydrogens. We need to cross check with alpha hydrogens. If more alpha hydrogens, the compound is more stable. So no need of bulkiness or nothing, we won't see anything. Okay? So then afterwards, something is there in the resonance. I'll tell you in the next step. So is it clear, everyone? Now I'll give you one more question. Now, which tell me the stability order. Write the stability order. Come on, tell me the answer. Hmm. Write the question and let me know the answer. If you are confusing these structures, write the normal structures. How we need to write the normal structures? Huh? So write the carbon skeleton. So how many hydrogens are required? Put that many hydrogens. For example, here is positive charge now. Here is only one hydrogen. Color, I am writing the color. Which one? Okay. Your answer is second. Okay. Okay. Remaining guys. Who would you answer? Which carbocation is? So in A case, how many alpha hydrogens? No? In A case, 4. 4. 3. So here, this is alpha, this is alpha. Huh? 3. 3 alpha hydrogens. B, here is 2. Here is 2, 2, 1, 5. C case, no? 3, 3, 1, 7. Here is only 1. Okay. If anybody confusing to write the alpha hydrogens, write the structure skeleton like this. Cross check with the carbon. If the carbon is having write 2 bonds, so remaining 2 bonds write with hydrogens. Because always carbon is having 4 bonds, right? Now which is more stable? C, 7. Yes or no? Then 7, 5, 3, 1 run. So CB, CB, AD. CBAD. Got it? Hello. Anybody still having any doubt? We don't know how to identify the number of carbon atoms. Write like this and let me know. Next, same type of question which I am giving you right now. Come on, I'm just giving you two only. So let me know which is more stable, which carbocation. Come on, fast. Easy question. Easy question. A or B? మొత్తం పోవాలని ఉందండి. Which one అన్నారు? Easy question only, right? Why are you taking this much of time? Hello. B. B or A? How many alpha hydrogens in A? In A, this is alpha, this is alpha, this is alpha. Yes or no? What, Nana? Alpha hydrogen means I told you, right? Carbocation. So this is the carbocation carbon, right? Adjacent. The carbocation adjacent carbons were called as alpha carbons. So those carbons, if it is having the hydrogens, those hydrogens were called as alpha hydrogens, right? Huh? So in this case, how many hydrogens here is? Two bonds are there, means two hydrogens here. In this case, already three bonds are there, only one hydrogen. In this case, two hydrogens. 2, 2, 1. How many? 5. So now here, this is alpha, this is alpha, this is alpha. Here is 2, here is 2, here is 2. 6. 6 alpha hydrogens. Here is 5 alpha hydrogens. Which is more stable? Which is more stable? B. Got it? What is alpha? Clear? Anybody still having any doubt? Do one thing. I'll give you normal structure right now to avoid the confusion. Okay, now? Hello? Okay, this is option A. Write the options. Yeah, tell me the answer right now. What is alpha carbons, Nana? First case. This is alpha, alpha. Carbocation adjacent carbons, okay? In this case, how many alpha? 3. In this case also, in A case, how many alpha hydrogens? A. 3 plus 2, 5. B. B. 8. C. C. 9. D. 7. Gautam, clear? Ah. So now, which is more stable? C. Then B. Then D. Then A. Got it? So if they are giving the questions like this, do one thing, write structures are like this. If you are confusing, can write the structures like this. So then automatically we can solve. Okay, now? Try one more. Write the questions. Right now, I'm just teaching you only the fundamentals, right? So a couple of days I'll teach this type of fundamentals. Then I'll enter into the original topic. Okay. So meanwhile, you should understand what is alpha carbon, what is a carbocation, and what is rearrangement. Because I used to the wording electrophile, what is nucleophile, what is electrophilic addition reaction, what is substitution, what is elimination. So which type of reaction? A lot of terminology which is coming. So before that, I'm just keep on using here is more a number of alpha hydrogens is there. So when I'm using that word, you could understand what exactly happening over there. Sir, what is alpha carbon? If you are asking over there, so it's very difficult task. Okay, simply follow me that fundamentals. Once it is clear, so the remaining original topics are very easy. Got it? So this is coming in the hyperconjugation, then resonance. One of the important things. A lot of people are confusing this particular fundamentals. So that is the reason I am just teaching you the fundamentals only. The people who are watching this video, right? So that is this video for dedicated for the people who are new, who don't know anything. If you are already advanced or if you are already pro mode, this video is not suitable for you. So please, you can skip video and you can watch other video. Thank you for watching. Disclaimer. People, అరే వచ్చి ఫండమెంటల్స్ నేర్పిస్తుండేరా అని వీడియో చూస్తారు కామెంట్ చేస్తారు. ఓకే. ఏనా బీనా థర్డ్ వన్? గౌతమ్ అర్థమైందా? తెలుగు వస్తుందా? యూనో తెలుగు? తమిళ్? ఏ తమిళ్? ఐ థాట్ యు ఆర్ తమిళ్. The first case చెప్పు Gautam is the answer. A లో ఎన్ని ఉన్నాయి alpha hydrogens? How many alpha hydrogens are there? 7 ఆ 8 ఆ? ఇక్కడ చూడు ఇది 3 రా, ఓన్లీ 1 కార్బన్ కదా, అంటే 3 హైడ్రోజన్స్ కావాలి. కార్బన్కి ఒకటే చూసుకోవాలి, క్రాస్ చెక్ చేసుకోవాలి. ఇక్కడ ఒకటే కార్బన్ అంటే 3, ఇక్కడ 2, 3 + 3 + 2 is 8, రైట్? 8. Like that we need to do. So remaining things I'll discuss tomorrow, okay? So tomorrow I'll take the class, okay? I'll text you today. How I text you almost all. If the class is there, I'll text you. If class is not there, I won't text you, because in the beginning classes, that's the reason I'm just taking couple of days. So once the batch is settled, so I'll go regular mode. Okay na? Hello.